Long before the reign of the dinosaurs, the Earth witnessed an era dominated by a diverse array of gigantic amphibians and other remarkable creatures. This period, known as the Paleozoic era, specifically during the Carboniferous and Permian periods, was a time when the landscape teemed with life forms both bizarre and majestic. The Age of Amphibians marked a pivotal chapter in the evolutionary history of life on Earth, showcasing a world where amphibians reached sizes and diversities that are hard to imagine today. The Carboniferous period, a time of lush, swampy forests and a rich oxygen-rich atmosphere, was the backdrop for the rise of the first great terrestrial vertebrates. This era, often heralded as the Golden Age of Amphibians, saw these creatures reach sizes and diversities unparalleled in the annals of prehistory. The environment of the Carboniferous, with its vast and dense forests of ferns, horsetails, and club mosses, provided an ideal setting for the evolution of these giants. Among the most iconic inhabitants of this period were the amphibians, creatures both fascinating and formidable. The high oxygen content of the atmosphere is believed to have been a key factor enabling these amphibians to grow to such massive sizes. Unlike modern amphibians, which are generally small and confined to moist environments, the amphibians of the Carboniferous period were true giants of their time, dominating the terrestrial ecosystems. Eryops, one of the most well-known of these giants, exemplifies the scale and adaptability of Carboniferous amphibians. Growing up to 2 meters in length, Eryops had a robust skeletal structure, powerful limbs, and a wide head filled with sharp teeth, making it a dominant predator in the swampy waters. Its semi-aquatic lifestyle was supported by its sprawling posture and tail, which was likely used for propulsion in water. Another remarkable creature of this era was Diplocaulus, easily recognized by its unique boomerang-shaped head. This adaptation is thought to have served multiple purposes, from aiding in steering and stabilization in water to possibly acting as a deterrent to predators. The wide head of Diplocaulus, spanning nearly a meter in some specimens, makes it one of the most distinctive amphibians of the Carboniferous period. The amphibians of the Carboniferous were not only large but also diverse. They occupied various ecological niches, from top predators like Eryops, hunting fish and smaller amphibians, to more specialized forms like Diplocaulus, which might have sifted through the mud for invertebrates. This diversity underscores the amphibians' central role in the ecosystems of the time, serving as both predators and prey in a complex web of life. The swamps and waterways of the Carboniferous forests teemed with these and other giant amphibians, creating a world that would seem alien to us today. The abundance of life, coupled with the unique environmental conditions of the period, fostered an explosion of evolutionary innovation. This era laid the groundwork for the evolution of more advanced vertebrates and set the stage for the dynamic changes that would follow in the Earth's history. As the Earth transitioned into the Permian period, the stage was set for a new chapter in the evolutionary arms race. This era, marked by drastic environmental shifts towards drier conditions and the emergence of extensive terrestrial ecosystems, witnessed a rise of some of the most formidable predators of the Paleozoic era. The decline of the Carboniferous swamps led to the diversification of terrestrial habitats, which in turn fostered the evolution of a wide array of predatory species, each adapted to the challenges of life on a changing planet. Among the apex predators of the Permian were the giant amphibians, successors to the Carboniferous giants, which continued to evolve and adapt to the new world. The Permian period saw the emergence of creatures like Prionosuchus, a behemoth among amphibians. Stretching up to 9 meters in length, Prionosuchus is believed to have been one of the largest amphibians to ever exist. Its crocodile-like body and elongated jaws filled with sharp teeth suggest a lifestyle akin to modern crocodilians, lying in wait for unsuspecting prey to come within striking distance. Prionosuchus dominated the waterways of the Permian, but it was not alone in its reign. The terrestrial landscapes were roamed by equally impressive predators, such as Dimetrodon. Although not an amphibian but a synapsid, a group closely related to the ancestors of mammals, Dimetrodon is often associated with the imagery of the Permian predators. Known for its distinctive sailback, which may have served as a thermoregulatory device or a display structure, Dimetrodon was a formidable hunter. Its strong, splayed limbs and large skull equipped with sharp teeth made it an efficient predator, capable of taking down a variety of prey. The Permian period also saw the diversification of reptiles, some of which adopted predatory lifestyles. These early reptiles, ancestors to both modern reptiles and birds, developed new adaptations for hunting, including more advanced jaw mechanics and sharper teeth. The evolution of the amniotic egg during this time allowed these creatures to lay eggs on land, freeing them from the need for aquatic breeding grounds and enabling the further spread of reptilian predators across diverse terrestrial environments. The end of the Permian, however, brought about one of the most significant mass extinction events in Earth's history, dramatically reshaping the course of evolution. The Permian-Triassic extinction event, often attributed to massive volcanic eruptions and subsequent climate changes, decimated a vast majority of life on Earth, including many of the period's top predators. This cataclysmic event cleared the way for the rise of new life forms in the Mesozoic era, setting the stage for the Age of the Dinosaurs. The journey from water to land is one of the most pivotal chapters in the story of life on Earth, marking a monumental shift in the evolutionary trajectory of vertebrates. This transition did not occur overnight, it was the culmination of millions of years of gradual adaptations and innovations that enabled aquatic organisms to venture into and eventually thrive in terrestrial environments. The foundation for this monumental shift was laid during the late Devonian period, setting the stage for the diversification and dominance of terrestrial life forms in the subsequent Carboniferous and Permian periods. One of the critical adaptations in this transition was the evolution of limbs capable of supporting the weight of an organism on land. The early tetrapods, descendants of lobe-finned fish, developed sturdy, limb-like appendages with digits, allowing them to move across shallow waters and muddy flats. These anatomical changes were accompanied by the development of stronger skeletal structures, including a more robust spine and pelvis, to support their bodies against the pull of gravity outside the buoyant aquatic environment. Another significant adaptation was the evolution of lungs and the ability to breathe air directly. While many early tetrapods retained gills for aquatic respiration, the development of lungs allowed them to exploit the oxygen-rich terrestrial atmosphere. This dual respiratory capability was crucial during the early stages of the transition to land, providing a survival advantage in variable and sometimes arid environments where aquatic habitats were not always available. The shift to a terrestrial lifestyle also necessitated changes in sensory systems and reproductive strategies. Early terrestrial vertebrates evolved mechanisms to prevent desiccation, including tougher, more impermeable skin and the development of the amniotic egg. The amniotic egg, with its protective shell and internal membranes, was a revolutionary adaptation that allowed embryos to develop in a controlled environment on land, free from the need for an aquatic nursery. This innovation laid the groundwork for the success of amniotes, the group that includes all modern reptiles, birds, and mammals. Moreover, the transition to land brought about new challenges and opportunities in finding food and avoiding predators. Early terrestrial vertebrates diversified their diets, feeding on the abundant plant life and invertebrates of the Devonian and Carboniferous forests. This new ecological niche drove the evolution of diverse feeding mechanisms, from herbivory to predation, each adapted to the challenges of terrestrial foraging. The transition to terrestrial life was not a linear process, but a complex series of evolutionary experiments, with many early tetrapods maintaining close ties to their aquatic origins. These pioneering organisms, through a combination of morphological, physiological, and behavioral adaptations, laid the foundation for the incredible diversity of land-dwelling life forms that would follow. The closing chapters of the Paleozoic era, particularly the Permian period, marked a dramatic and transformative period in the history of life on Earth. This era, known for its rich diversity of amphibians and the emergence of early reptiles, came to a cataclysmic end approximately 252 million years ago with the Permian-Triassic extinction event. This event, the most severe mass extinction in Earth's history, signified not just the end of an era, but a profound reshaping of the planet's biological landscape. The Permian-Triassic extinction event, often referred to as the Great Dying, wiped out an estimated 90% of all species. The causes of this mass extinction are believed to be multifaceted, involving a combination of volcanic eruptions, global warming, ocean acidification, and possibly asteroid impacts. The massive volcanic eruptions in what is now Siberia are thought to have played a significant role, releasing vast amounts of carbon dioxide and other gases into the atmosphere, triggering a cascade of environmental changes. For the giant amphibians that had thrived in the lush, swampy environments of the Carboniferous and Permian periods, the rapid environmental shifts proved catastrophic. The drying of the planet's landscapes, the loss of shallow freshwater habitats, and the drastic changes in climate rendered their survival increasingly untenable. These once dominant creatures, unable to adapt quickly enough to the rapidly changing conditions, were among the countless species that vanished during this time of upheaval. However, the end of the Paleozoic era and the extinction of the giant amphibians also paved the way for new life forms to emerge and diversify. In the aftermath of the extinction, the vacant ecological niches left behind by the decimated species offered unprecedented opportunities for the survivors to expand and evolve. Among these were the early ancestors of mammals and dinosaurs, which would come to dominate the Mesozoic era that followed. The Mesozoic era, often hailed as the Age of Dinosaurs, witnessed the rise of these reptiles to become the new masters of the Earth's terrestrial realms. The dinosaurs, with their diverse forms and adaptations, filled the void left by the amphibians, occupying a wide range of ecological niches from predators at the top of the food chain to herbivores that fed on the era's abundant plant life. This period of recovery and diversification underscored the resilience of life and its ability to rebound from even the most devastating of catastrophes.